So when you have a problem involving forces, there are several steps that you need to take into account to solve your problem. So let's start by an example. If you have an object that is moving due to, let's say, a force, so this object might have a friction force, and obviously this object has a mass, so it will have a weight, and then it has a normal. So the first thing you do when dealing with forces is to construct what we call the free body diagram. What is the free body diagram? Is to take your object and to see which are the forces that are acting on it, and then you represent your object with a dot, and then you have, for example, in this case, you have a force acting on this, and you have to keep the angles. Let's say this is an angle with the horizontal axis, and then you have a normal, you have the friction, and you have a gravitational force, the weight. Okay. So this is the first step. The second step is to build or to write down the second law of Newton. Second law of Newton is the sum of the forces acting on this object is equal to the mass of the object times the acceleration, which in vectorial form, in this case, will give F plus N plus capital F, the traction force, plus W is equal to ma. Okay, so now let's assume that, in this case, the acceleration is this way. So the object is moving to the right. So this is the second step. The third step is to look at this free body diagram and the second law of Newton and project it along the axis that you have chosen. So for us, this is the x-axis and the vertical is the y-axis. Okay, so in this case, for example, you project your force or the second law of Newton along the x-axis, and you can easily see that it is F cosine theta. Okay, the projection of F. The projection of the friction is minus F because it's in the opposite direction of the motion, and it is parallel to the anti-parallel to the direction of motion. The normal has no components along x, and the weight has no components along x. And the acceleration is not a force; it just gives us a direction of the motion. Okay? So it is equal to ma. So I will call this equation 1. And then along the y-axis, you take the same thing, this equation, and you project it along the y-axis. You can see that the friction has no component along the y-axis. The normal has a positive component, and the force now has a sign. Okay, so plus a positive sign theta, and the weight, you can see that it's in the opposite direction of the upward y-axis, so which is minus w. It is equal to the projection of the acceleration along the y-axis, 0, because there is no motion along the y-axis. So you would have obtained two formula, and we know that the friction is also equal to the coefficient of friction times the normal. Okay, so those are the steps. So now you have 3 equations, and then you can solve your problem. So let's give some examples. Let's consider this. So let's look at this problem. So this problem, we have 2 objects, mass m1 and m2. They are attached by a rope that has no mass, and they go to the rope goes through a pulley which has also no mass. And the question, so both, so the tension T1 is the one acting on object M1 and M2, and also there is a tension or a traction force T2 that is trying to pull the whole object into this direction. And we have the acceleration. So the whole system is moving thanks to this traction force T2 to the right. So let's start by the free body diagram. So the first question is, what is the tension T1 of the rope connecting M1 and M2? So the question is mostly about T1. Let's calculate or draw the free body diagram of block 1. So block 1, you can see easily that in block 1, there is tension T1 that is acting on it, and then the gravitational force, okay? And the acceleration is in this way. And if I take the y-axis, and the sum of the forces is equal to m1a. There is only a projection along the y-axis, because for object m1 there is no motion along the x-axis. So you can easily see that the projection of this along the y-axis gives us T1, which is in the same direction as the opposite side of the y-axis, minus W1 is equal to M1A. Okay, A is positive because its projection is positive because A is the same direction as the positive direction of the y-axis. So this gives me T1 is equal to this, and we know that W1 is M1, so it's M1 times A plus G, and we have everything. We have M1 and we have M1, A, and G. So the second question is about the tension 2. Now, tension 2, second question, tension 2, or the traction force 2. So here we need the free body diagram for object 2. So again, for object 2, it's very important. Object 2 has a traction force that is pulling it to the right, and it has also a tension T1 in the opposite direction. Remember, the tension goes from the object to outside. And then obviously it has a normal force and W2, the gravitational force. Now we can easily construct our x-axis in this direction and the y-axis in this direction, and we know that the acceleration is going to the right. Now remember, the acceleration is not a force. It's not part of the free body diagram. So let's write the second law of Newton. The sum of the forces acting on object 2, okay, are equal to the mass of object 2 times the acceleration, which is, in our case, T1 in vectorial form for the moment, W2 plus N plus T2 is equal to M2A. Now let's project along the x-axis. So along the x-axis, you can see that T1 has a negative projection. W2 has no projection because it's perpendicular to the x-axis. The same thing for the normal. And there is only T2 that has a projection along the x-axis. Okay. And so this is equation. And then the y-axis, you can see that T1 has no projection along the y-axis, neither to T2. It's only N minus W2, and it is equal to 0 because there is no motion along the y-axis. The whole system is moving horizontally. So this will be the equation that will be useful for us. So T2 will be equal to T1 plus M2 times A. So this answers our question. This is a very simple problem, but it can show you how to build the free body diagram and how to deal with the tension. Remember, one very important remark here: we did not do any free body diagram for the pulley. Why? Because the pulley does not have a mass. So later in this course, we will have cases where we will construct or build a free body diagram for the pulley. So let's go to another problem, another example, which is an inclined plane. Okay. So this is an inclined plane, and the question, so the question here is, so a block of mass M1 that has 40 kilogram constrained to move along a plane inclined at an angle alpha to the horizontal is connected via massless rope that passes over a massless pulley to a second block 2 of mass M2. So the question is, what must be the mass of block 2 for the system to move to the right? So the system to move to the right means you have an acceleration this way, and this object will have an acceleration this way. Okay, so now let's build the free body diagram of both objects. So let's start by object 2. So block 2. Free body diagram of block 2. So we know that there is a tension here in the cable that I will call it T. So the free body diagram, this is M2. It has the weight that I will call W2, and it has a tension, and obviously the acceleration is this way. Now, if I choose my y-axis in the upward direction, then the second law of Newton applied for block 2 is the sum of the forces acting on block 2 equal to the mass of block 2 times the acceleration. So, which in this case, T plus W2 is equal to M2A. Now, if I project this along the y-axis, you can see that T is positive and W is negative, and also the acceleration is negative. Okay, this is an equation. Let's say this is equation 1. Okay, this is equation 1. Now, let's look at the free body diagram of block 2. So now, free body diagram, again, if I take this, let's say this is the inclined plane, and block 2 is this, you can see that the normal is, this is the normal, this is the tension in the rope, and this is the W1 gravitational force. There is no friction. So we have an angle alpha here. It means that our angle alpha is here. Okay, right? Now, the acceleration is in this direction. So it would be nice to take the x-axis parallel to the motion in the same direction of the motion. So now we have a free body diagram, and the free body diagram will give us the second law of Newton applied to object 1, which is equal to the tension plus W1 plus the normal, and it is equal to M1A. Now let's go and project it along the x-axis. Okay, let's project this along the x-axis. If I take the x-axis, the projection of T along the x-axis is a positive because it goes into the same direction of the x-axis. The projection of W1 along the x-axis is this one. You can easily see that it's equal to a minus sine minus W1 sine alpha. Now minus because it's in the opposite direction of the y-axis, and sine alpha because this angle is 90 degrees minus alpha, so cosine 90 degrees minus alpha is sine alpha. Okay, and then there is no projection of the n along the x-axis because n is perpendicular to the x-axis. It is equal to M1A, right? M1A, and this I will call it equation number 2. And then along the y-axis, you can see that there is no component along the y-axis of T. There is no component, yeah, and there is a component along the y-axis of N. And then again, if you project the W1 along the y-axis, it is a negative, but with cosine alpha. And it is equal to 0 because there is no motion along the y-axis. The object is moving perfectly parallel to the x-axis. This is equation number 3. What is the question now? Question is, what must be the mass m2 for the object to move to the right? We already assume the object to move to the right by choosing the acceleration to the right. So now we will take equation 1 and equation 2. We have no friction, so we will not use equation 3, and we will see what will happen. So obviously we don't know the tension. So equation 1, we can use it to get the tension. The tension will be from equation 1 is equal to Wm2 minus M2A, okay, is, yeah, so this is, I will call it, this is equation 4, and I will plug equation 4 in equation 2. I will replace T by its value. So it will give me W2 minus M2A minus W sine alpha is equal to M1A. So let assemble A's together, the accelerations. So this will easily, you can easily see that it will give you M1 plus M2 acceleration is equal to W2 minus W1 sine alpha. So the acceleration will be W2 minus W sine alpha divided by M1 plus M2. If the object has to move to the right, this quantity must be bigger than 0, positive, because we chose the acceleration in that direction. So our analysis should give us a positive acceleration. So what does this mean? This is positive. So this means that W2 minus W1 sine alpha must be positive. And we know that W2 is M1, M2, G, etc. So it's M2 minus M1 sine alpha must be 0. So the condition is that M2 must be bigger than M1 sine alpha. So the mass of object 2 must be equal to the mass of object 1 sine alpha. Okay, so this is how we can solve this problem. So later we will solve the same problem, but including the friction.